Hello, this is Santosh Shinde, IT Department, VPKB IT Baramati. Today I am talking about some part of fifth unit, especially instruction level parallelism, MIPS implementation and introduction to instruction level parallelism. So this is the agenda of Unit 5. Mainly it focuses on MIPS and pipelining. So this video will introduce you to MIPS to little depth and introduction to pipelining. So what is MIPS? MIPS is one type of risk architecture, as we had seen this little bit about this in the third unit while we learned risk architectures. So we know that core MIPS instructions, including the integer arithmetic logical instructions, the memory reference instructions, and the branch instructions. Much of what needs to be done to implement these instructions is the same, independent of the exact class of instruction. For every instruction, the first two steps are identical. If we see overview of MIPS architecture, this is MIPS architecture and it consists of PC, that is program counter. We know PC always points to the address of the next instruction to be executed, and the size of this instructions in MIPS is 32 bits. This is the register bank. It has 32 registers, each of size 32 bits. There is a separate data and instruction memory. So it has a cache memory which is divided equally into two halves of instruction memory and data memory each. So we have a program counter to the send the program counter to the memory that contains the code and fetch the instruction from that memory. Read one or two registers using fields of the instruction to select the registers to read. For the load word instruction, we need to read only one register, but for most of the other instructions, we require two registers. The simplicity and regularity of the MIPS instruction set simplifies the implementation by making the execution of many of the instructions classes similar. This is the ALU, that is arithmetic and logic unit. This is how PC is incremented by 4, since the size of each instruction in MIPS is 32 bits, that is 4 bytes. So PC, which contains the address of the next instruction to be executed, is always to be incremented by the size of the instruction, and here the size of the instruction is 4 bytes. That's why this is the adder unit, which it takes the current value of PC and adds 4 into it, and then this way it comes back like this. This is the single data path for MIPS architecture. So we start with PC, read the contents of PC, and then we have the instruction memory. Next in the path comes registers. Then the ALU through MUX, it takes selects the values and then forward it to the data memory. This is simple MIPS implementation with control signals. So as you can see that there are control signals for register read write, and there are control signals for this MUX. There are control signals for data memory read write, for memory read and for memory write. Like this, we have separate control signals. There are control signals for the ALU to perform some operation. Control signals are represented using blue lines, and there are control signals to choose among these MUX. And there are control signals even for the registers. So this diagram shows the same one, but MIPS implementation with control signals. Okay, and these are the control lines. 000 is AND function, 0001 is OR, 0010 is add, 0110 is subtract, 0111 is set on less than, 1100 is NOR, like that. Now, little bit about introduction to pipeline. Pipelining, what is pipelining? It is a strategy for employing parallelism to achieve better performance, and it is inspired from the assembly line in mechanical field. Implementation technique in which multiple instructions are overlapped in their executions. Okay, we use this in our real life, like in laundry and in factory production lines. So this is how in laundry we use it. This is how pipelining is used in laundry. Sequential laundry, whereas pipelined laundry is shown down the line. And then this is quickly very simple to understand the laundry example. Automobile team assembly is another example. So raw product comes and it goes through variety of tasks 1, 2, 3, 4, and all them are overlapped in their execution. Okay, so this is about the assembly line. Instruction pipeline. Now we are more interested in instruction pipelining in computers. Instruction pipelining is CPU implementation technique where multiple operations on a number of instructions are overlapped. So there is overlapping of multiple operations of a given instruction. Okay, how this is done? You can see that this is instruction I1 and it consists of two, let's say, operations fetch and execute, fetch and execute. This is sequential execution, and the same if you can parallelize it like this. This is the clock cycle 1, 2, 3, 4. So at clock 1, instruction 1 is being fetched. At clock 2, instruction 1 is getting executed and simultaneously instruction 2 is getting fetched. At clock 3, instruction 2 is getting executed, whereas instruction 3 is getting fetched simultaneously, and so on and so forth. So this is how pipelining works. Thank you.